Hello everyone. Let us recall dilation. Sometimes we need to enlarge or reduce the figures during designing. However, in every case, the figures must be similar to the original one. This method of drawing enlarged or reduced similar figures is called dilation. For example, over here we have original rectangle ABCD in blue color, and then we have an enlarged one in green color. Here, origin is the center of dilation. The center of dilation is the fixed point in a transformation from which all the points of the figure are expanded or contracted. If you look over here, AB is 2 units and A dash B dash is 4 units. Similarly, AD is 1 unit, but A dash D dash is 2 units. So the green colored enlarged rectangle is twice in size. Here we can say that the scale factor is 2. Scale factor is a number that tells you how much a figure is enlarged or reduced during a transformation like dilation. It is actually the ratio between the dimensions of the new figure and the original figure. For example, here the dimension of the new figure A dash B dash, the length here is 4. In the original rectangle, the length is 2. The ratio of 4:2 is 2. So our scale factor here is 2. Another thing to note is whenever the scale factor is greater than 1, it will enlarge the figure, while a scale factor between 0 and 1 shrinks it. For example, if a scale factor is 1 by 2 or 0.5, our dilated figure will be half the size of the original figure. Now, let us construct a dilation with the scale factor 2 of a triangle using compass. So first of all, we need a triangle. So let's draw a triangle PQR and then choose a center of dilation, C, which is not on the triangle. It can be outside the triangle, it can also be inside the triangle. Here, in this case, we are taking it outside the triangle. Then, join every vertex of the triangle from C and produce a dotted line. So we are going to connect C to P, Q and R and produce this line ahead. Now, our step 2 is to mark 3 points. So using compass, we will mark 3 points P dash, Q dash and R dash on these dotted lines such that CP dash is K times CP, where K is the scale factor which is 2. So this is twice of CP. Now I need a point P dash over here such that CP dash is 2 times CP. Let's keep a compass needle at C and measure CP. Now we can do one thing. We can just take a ruler, measure this CP and then take twice the length, open the compass and make an arc over here. Or since we have already opened the compass to the length of CP, we can keep the needle at P now and make this arc and call it P dash. Let's say if CP was 2 and then we have made another arc from P to P dash, this would be 2 as well. So CP dash is 4, right? Now we also need CQ dash and CR dash, which are again twice the size of CQ and CR respectively. So we repeat the process. Keep the compass needle at C to measure CQ, then keep it as it is at Q and make an arc. Call this Q dash. Same process for CR. Keep the needle over here, compass over here, measure it and make an arc and call it R dash. Lastly, we'll join P dash Q dash, Q dash R dash and R dash P dash. Over here, this new triangle P dash Q dash R dash is similar to the original triangle PQR. Now, if we need to, let's say, construct this triangle with a scale factor of 1 by 2, all we need to do was measure CP, then take half its length and make an arc over here. Similarly, measure CQ, then take half its length and make an arc over here. And then join those 3 points. And we would get a reduced triangle with scale factor 1 by 2.